Hello, everyone, and welcome to another episode of Advent of Code in Rust, the live show where we try to solve Advent of Code challenges and try to learn Rust in between. If you've never done Advent of Code before, it's a yearly challenge that happens generally around Christmas, the 24 days before Christmas, and you get a number of programmatic challenges to solve. We are working through the ones from last year, so 2020, and you can find Advent of Code here and all our code in this nice repository here. By the way, my name is Luciano and I am joined by
Roberto.
Okay, so what do we do? Yesterday we tried to solve exercise number 20, the second part. We did already solve the first part. The second part is much more complicated. I was actually reading online that some people think is the most complicated of that particular year. So it's kind of a relief that it's not only us struggling with it. But I think we have unblocked the point where we got stuck yesterday. But maybe it makes sense before we continue to try to explain again what we are trying to do and the algorithm that we want to implement. And
Yes.
Roberto, you did prepare some slides, right?
Yes. We want to share them.
Yes.
Can you see them?
Maybe if you can make them a little bit bigger.
Oh, I don't know.
I can probably put it full screen, by the way, meanwhile.
Because, okay, I don't know if I can. Better? No? Yes? No, just square.
Okay, can you do a control plus? Does it improve?
If I do control plus, it's making
okay, funny.
Control.
Okay, let's continue like this. I mean, I think we can explain it anyway.
Yeah, I can. Here there is array of U16, 12, 12. That is what we already did yesterday. That is our tile map.
Mm-hmm.
And we start in the tile map with the corner, one of the corner that we just choose in a corner. And when a corner has, obviously the corner has two neighbors, and we put the two neighbors, one on the right and one on the bottom. We don't care which one we put where. What we have at the end of this is just a flipped version of the image if we do the wrong way. And for part 2, this is not important. When we do this, we add in a stack because we wanted to avoid recursion. The number of the tile ID of this tile and these coordinates, the tile ID of this other tile and these coordinates. We pop from the front, so from above in this case, and we push in the back, so we at the bottom for based on how I wrote this stuff.
Mm-hmm.
After this first step, we go to the next one. The next one is taking the first element from this stack. So you see that 1147 is going to disappear. Yes. And we now have three neighbors of this cell because this cell is a border. We have three neighbors. But we can remove the neighbors that we already know. That is only 1120. We have two neighbors at this point. One go on the right and one go on the bottom. Which one goes on the right? On the right, it goes the one that is a border or a corner. And we have an hash set with all the edges and all the corners. So we can do that in a if. The other one goes below. When we have done with this, we push to the stack the one on the right here and the one on the bottom. What we did yesterday, the error that we did yesterday was this one, because we are looping on a hash set of neighbor. You don't always get the right one, then the bottom one. You have 50-50.
Mm-hmm.
So we were adding in this stack, in the wrong order, the two tiles that we have to process next. And this was leading to errors. Today we will fix that.
By the way, we suspected that because I remember we were getting different results every time we were running the test.
Exactly. Because basically 50-50, you get paths that are not, you can get all possible paths of these branches. And you got the right intuition, but we didn't have time to fix it. Now, Next step again is popping one element from the front. At this point, the element on the front will have 3 neighbors, but 2 of them are already defined. So obviously the third one go on the bottom. And you push it to the stack.
By the way, I want to mention that we are going in this kind of pattern of diagonals from the right to the bottom left.
Yes.
Top right, bottom left, basically.
Yes.
And that's because the way we kind of fill one of the blanks, and it gets easier to match another neighbor.
Yeah, the only moment when we have 2 neighbors and we have to choose which one put on the right and which one on the bottom is when we are in the first row and we are going right on the first row. But luckily, we know that what we have on our right is a border or a corner, or always. Then again, we pop a number 5475. That was the first one in our stack here. We pop it, we choose what to put on the right, what to put on the bottom, and we add them to the stack again. Then we go to the next one, and we only have to, these will have 4 neighbors, this cell will have 4 neighbors, but 3 of them are already defined. If we go here, this cell has already 3 neighbors, so we know that the one that is left go on the bottom, and we put it in the stack. Then we go on the stack and we pop again. We are in this cell has 3 neighbors, but 2 of them are already defined, so the one that is missing on the bottom, and we push it to the stack, and then we go on like this until we run out of stack, because now the stack is increasing, but when we reach the right border, the stack will start to decrease again up to the moment when it basically exhausts itself. So this is the idea, and our error was just that when we do this choice on what to put on the right and what to put on the bottom, we have to stick with push to the stack the right one, then push to the stack the bottom one, and that was our mistake.
Yeah, this way we make sure that we always have a deterministic choice, because we are excluding all the other options.
Yeah, and also because we always, when we are in an internal cell, we always assume that the one that is missing is the one on the bottom, because the one on the right is already done from before. So in our code,
so this is the code from yesterday where we left it at.
Yeah.
And where is it that we push to the right?
Yeah, it's line 195 and line 199.
There, yeah. 90.
Yeah, we don't have to do them inside the loop. We have to do them outside of the loop.
So we need to assign.
No, it's just enough to do that outside of the loop. Because another stuff that I noticed is that we are saving n, but we could it could also work with only the coordinates in the stack, because n is already in tile map, so we could read from there. It's just easier for us. So remove those 2 stack and put them outside of the loop, the for loop, but inside the if.
Here.
Yeah, there. And also the other one. Yes.
Do we want to do that change where we remove n?
No, not for now. We can refactor it when we have something.
Okay, so basically this becomes tile map
of
row column
of row column plus 1. Yeah. And the other one is tile map of the row plus 1 column. So we add the one on the right, this column plus 1, then we add the one on the bottom that is row plus 1. If we are lucky, everything now is working.
And this one?
That one is with only 1 element, so we don't have problems. Probably there we could have another out of bound if we are in the last line and we try to add something, but we guard it with an if only if needed. Because when you have the last tile in the bottom row, it's useless to put that in the stack, because all the cells around that cell are already fine and done. So yeah, make not a lot of sense.
So basically, if we run the test for this line, we expect to see a tile map where for every position we have a unique ID.
Yeah.
Let's see if that's the case.
It's not beautiful printed. Yay. It's not beautiful printed because, you have to put
Okay,
them
fair enough.
one.
But it looks like we don't see any zero, which is our
Exactly.
number for empty cell.
If we run this again, we could have a different result because, for example, now our top corner is, if you go to the first number in this, 2711 is our top corner. If we run it again, the hashmap is not deterministic, so we could have a different corner. But this must not change the image, it's just rotating it.
Okay, yeah, because it means we are picking a different corner to start with, so everything else will be somewhat flipped or rotated. Yeah,
exactly.
Okay, so now what do we do next? Because at this point we only know through this tile map where every tile is positioned, but we need to rotate it or flip it in a way that all the borders are matching with the neighboring ones.
Yes, we have to create the final image. That is this huge array of charts.
See if in the README we have an example.
Yeah, that one.
I think this one. So basically from this one, where here they are already rotated because you can see that. Are they? No. Wait. Here they are not matching.
No, they are not matching there. But no, not even. Why they are not matching?
Oh, because they already removed the border. So this is the actual.
Okay.
So they are starting from this one.
Okay. I think not, because it makes not a lot of sense.
Yeah.
Okay, go down.
Yes, they remove all the borders, even the outer ones.
Even the outer one?
Yeah, this should have been the top
okay.
border and it's diff. So that's interesting to know. Well, by the way, we can also count the number of 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So they always reduce every single tile from a 10 by 10 to an 8 by 8.
Line 186. The border of each tile are not part of the currently image. Start by removing them. So we have 8 by 8. And the image is 12 by 12 tiles. So 12 by 8, how much it is?
Calculator.
96.
96, yeah.
96. So our final, we can allocate an array of charts of 96 by 96 and start to fill them.
Yes, but we need to figure out the rotation because, for instance, if we look at this one, this is before removing the borders. In our current solution, we just have the IDs of every tile, but we didn't rotate them so that the borders match. Like, for instance, this border here is the same here. This one here is the same here. In our case, we don't really know if they're rotated or flipped accordingly. So I think that's the first thing we need to resolve.
So we can go through our tile map. We have the ID. When we loop through our tile map, we take the ID, and we have the borders, right? We have the array with the 8 borders because they are the flipped version and top left, right.
Here, borders, yes.
Yes, there are 8 of them. And also, okay, at that point, let's think that we start with a corner, right? The corner must match on only 2 of them.
Yes.
And based on those 2, we know that we want the top left corner, which is our start one. If the top left corner, our tile, matches with the board that is called the top and left, it means that we have to rotate it 180 degrees to get to the right place.
I'm thinking if there is a more, let's say, deterministic way where basically this border is a list is like the position is going to be always the same for the same original position of the border. The way we built it is basically we do
top, rotated top,
exactly.
bottom, and so on.
I'm wondering if we can use this information to understand how to rotate and flip it. Because we know we are positioning to the right side of an existing tile or to the bottom of an existing tile.
We are at the start with the first corner, putting it in the top left corner. So we know that the border that must match something is the bottom and the right. Okay. And we know the neighbors because we have an hashmap of the neighbors. So we can ask between those two tiles, what are the common border? We can do a function that do that. Let's try to start with that.
Okay.
We do a function that given two tiles.
Let's do it. Where do we do it? Here.
A function that given two tiles, it gives us which is the border that match, and now you have to rotate the second one, just to say, or flip the second one to connect to what you have.
What do we call it? Fit tile.
Yeah.
And we have to get what, 3 tiles? Like top, left, and the new tile.
Well, we can start with just 2 tiles and try to match them. Why you want to do it 3?
Because my understanding is that we are in this situation. So we have, let's say that we have this one, this one, this one, and we are trying to position this one. Right? So we have this one, we have this one, and we are trying to figure out how to rotate or flip this one accordingly.
Yeah, okay, makes sense.
So this will be the top one, this will be the left one, and this is the new one.
Okay, I like it. And what about when we do the first row? That doesn't have a top. Do we pass a null? Can we pass a null in Rust? I don't think so.
We can pass an optional.
An optional. Okay. So the one on the left and the one on the top are optional. Because, for example, the corner. The corner.
By the way, can we look only at the left side?
Why not the top one?
Also here, no, we'll need to look at the top side as well.
Yeah, for the border on the left,
For this one, yeah.
The one on the left is optional, but the one on the top must be specified.
No, what I'm thinking is that we know that there is always one border matching.
With one
other border. So as long as we manage to overlap these two, like 2 tiles on one border, then we figure out the correct rotation.
Let me think about
regardless if it's top down or left right.
Yes, I think so. So do you just want to go by line?
So we could try to do one function where we only look from left and right, for instance, and then we can see if it makes sense to generalize that function with also top bottom or do another function.
But we already know what is the tile on our bottom.
But we don't know how it is rotated.
Yeah, you're right. Okay, let's go with just the one on the left and then see if we can use it also for the one on the top.
So just to recap, the assumption we are making is that we position the first corner as it is, because it doesn't make any difference to rotate or flip the first element. That becomes our anchor. Yeah. Then we know which one to put on the right and which one to put on the bottom. But at that point, for both of them, we need to figure out the correct rotation or flipping so that it matches the right side of the first tile, and the other one is going to match the bottom corner, where the bottom edge of the first tile.
Yeah, I just want to say that when we place the corner, probably we have to take a look at if we need to rotate it, because it could be that we are placing in the top left a tile that has the top and the left that are matching with the other tiles. This means that the corner must be flipped on both axes. But let's start to write the function that given two tiles, it gives you how to rotate the second one to match.
So let's call it anchor the tile.
Reference to tile is better.
Yes. And what is it gonna return?
It's going to return rotation and flipping, so we can do an enumerate of something.
Does it make sense to return a new tile? And then in the tile itself, we can implement the rotation and flipping as methods.
The tiles contains the
everything, like all the cells.
The cells, okay, yeah, so we can.
So basically what we can do here is to implement fn rotate, let's say counterclockwise or clockwise. What do you like, this way or this way?
No strong opinions.
Let's just call it rotate, it doesn't matter.
Yeah.
And this one takes self, reference to self, and returns a new self. So we intentionally create a copy just to make it non-destructive. Otherwise, we're going to keep changing references.
Yeah, and Rust is not happy about it, probably.
Okay, so how does it work at rotate?
Rotate, if this was Python, we could have do a zip of an expansion and so on.
We could probably use a zip, but basically we need to turn all the rows into columns, and that is basically a 90-degree anti-clockwise rotation, right? So we could do that.
In one of the direction that you want, yes. Clockwise, counterclockwise. I'm not opinionated about it. But just match.
Yes, okay. So what we do is we need to create an object that looks like this. ID, cells, and borders.
Cells and borders are the same. No, we have to compute the borders.
But we can use the new with ID and cells. So the only thing we need to do is to create an array of cells.
Okay, right.
And then we pass that one to the new function.
The new function, right.
So let's say let rotated cells. That's where this one is going to be n, and basically what we can do is self dot cells dot zip. What did you want to do?
I don't know if there is a zip in Rust.
Is there a transpose? No.
Because normally what you do in
Is a zip.
It's working like in
what does it give us? Returns a new iterator that will iterate over two other iterators. Returning a tuple, no, so it allows you to zip all the cells with another iterator.
No, it's not what I want.
Did you want an enumerate?
Basically, we have 8 rows, right? 10 rows in that cell, in the original cell. What I would like is just not a zip on top of them, but zip on top of something. And all the 8 arrays are an iterator passed to zip. Zip takes an infinite number of iterator, right?
Zip takes
only 2. Can't it
take once another iterator? Takes itself and another iterator,
and then zip together. Okay. Let's try this. Cells. And
by the way, if we do an enumerate, considering this is square, and then we map, we basically need to go for every I of that line, we go column by column and we return that and collect.
We return that as a char of 10 and we collect. Yes, it can work. Can you collect on an array?
Ooh, I think Tommaso did something there with vectors.
Yeah.
I think it's here, yeah. So we can do the same, try into unwrap, basically. But let's start with this. So we do a map, right? And in this map, what we get is
The index.
I and row.
Yeah.
And then what do we want to return?
We have to return an array with.
Actually, we don't even care about the row.
Yeah. We care about I.
Exactly. So we only need to return a new array.
Char of n, a new array char of n with all the elements of the column I, not of the row I, because we are going by row, but we want to return all the elements of the column I. How do we create it? For j in 0.n
dot I
n
dot n.
n capital
Yes. Oh, can we do that?
I don't know.
Let's see. Yeah, nice. Well,
We have to
need
create.
to do,
You have to do let mut char of n.
So column is equal char of n, and initially we do. What do we put? Empty strings, I guess.
Empty character with a single quote.
Oh no, it's a column. How do we do that? I was quite sure you could do that. Maybe it's a comma.
I was thinking it was a semicolon, to be honest.
Literal must not be empty.
Go with
okay.
Go with a space. Then we change it to something meaningful.
And then basically what we do is column of
call of
j
is equal
to column of is equal to cells.
Yeah.
I and j.
Let me think a moment. Just a second. Cells of. No, the first one is the row. So it's a cells of j in I think. Yeah. Okay. Probably it's better to write a test on this rotate. And then we have to return call. No? Yes.
And then we return call. Or we just say call.
Yes, sir.
I'm sure that there is a one-liner for all of this, but for now, let's just make it work.
Like always.
And now once we have the map, what we want to do is a collect.
Yeah, but collect with array was not complaining.
This is going to complain or not? Interesting. It's not complaining.
No, happy.
Okay, cool. So now what we need to return is tile new with
the same ID
self.id, then rotated cells, and that's it. I am surprised that it's not screaming.
Me too.
Okay, let's write a quick test for this.
Yeah, let's write a quick test for this.
And maybe because we have an error here, it was not complaining. Let's see if now complains. Okay.
Yeah. Okay.
Okay, and the trick I think is to do this. And I think I can explain why. I mean,
unwrap 2 times. No, only one.
Doesn't like that. A value of vec char
Yeah, because this is not a vec-char.
Oh, this is a vec of a vec. Is that gonna work? No.
No, this is a vec of array of char n.
Vec.
Array char, yeah, square bracket, char, semicolon n, close bracket, and okay, that now is happy. Why the
Comma didn't. Oh, yeah. Cool.
okay,
It did like
now,
this. Now here is gonna give us a smart suggestion on what to do. Range loop. Consider call either mute, enumerate, take n. Let's leave it for a second. Maybe after we write a test.
Yeah. I didn't understood that.
Okay, so let's do
Tile rotation test.
test fn rotate tile. And we can do a new tile
with a pattern that we can throw in by random.
We can even do like a 4x4 because our tile is generic.
If we have n, we can go 4x4. So it's
or 3x3 even, right?
We go 4x4, 3x3.
Okay. So let's say let cells, and we do cells needs to be char 4 and 4 of this, right?
Mm-hmm.
And that is equal to, we can say, I don't know, A, B, C, D.
Yeah, copy and paste. And then change that as like you want. What is that? That is an E, the one that you have there.
What?
The one before the F is with an accent or is just rendered very badly?
The one before?
The F. Second line.
I don't see anything weird, so maybe it's just
no, so it's just the
artifact.
streaming. Yeah, artifact of the streaming, sorry.
I don't know if I am missing any letter, but
Well, it's UTF-8, so fine. Let's create a tile with those cells, tile 4 with those cells.
And we do tile
4
from new.
We have to say the size of the tile with the angle.
And we call it 0 because it doesn't matter, and then cells, and we need to say that this tile is it gonna recognize on its own? Yeah, nice, because it's seeing the sides of cells.
Cool.
Given that it's a static.
Yeah, given that it's static,
it's not
is
coming
inferring the type. Very powerful.
Okay, and now what we want to do is let rotated tile and tile dot rotate. That should give us a new tile. And now what we want to assert is let.
Try to just print the bug, the rotated tile.
Rotated tile.
Rotated tile dot cells. I was not remembering it. What do we have there? Okay, so we have
AEIM. Correct. So BFJN.
More than rotated, this is flipped.
No, because this is the first row.
Yeah, but it must be MIEA.
Oh yeah,
we flipped on the diagonal from top left to bottom right.
So it's like we rotated it like this way, so 90 degrees.
flip it
No.
this way. We flip it like this. Tac.
So
we flip it on the diagonal that go from A to P. So go back in our
isn't
rotator.
it rotated 90 degrees and flipped as well, 90 degrees clockwise?
No, it's because A is still the first on top left.
Wait, let me do this very quickly.
Okay, sorry.
Let's say that this is our expected for now, even
if it's not true. Format can.
Oh, nice. Did the magic.
Yeah, you see, we flipped on the diagonal between A and P. This is a flip. What we have to do in our loop is not putting it as the first element, but as last element of the array.
So we need to do.
Where is the function? I lost it. Rotate.
Very top there.
When we do call of j, we don't have to do call of j. We have to do call of n minus 1 minus j. If we can use n in
I think so, because it's gonna just be replaced at compile time with whatever usides.
Try now to see what we have, and then after that copy and paste. So, and let the magic of the linter happen.
So now we have A, B, C, D. So now it's rotated 90 degrees
clockwise. Yeah.
Because it's A, B, C, D, E, F, G, H, E, F, G, H, I, J, K, I, J, K, L, M, N, O, P, M, N, O, P. Okay, cool. So now what we want to do is assert equal, and we do rotated tile dot cells and expected. By the way, we don't even need this, which is kind of cool. Now, if we run this test, it should pass. Yeah.
So we are able to rotate a cell. We are very.
Do we also need to implement flipping?
Probably yes. Like we just flip, but on one axis and the other one, because
actually, let me try that trick first. So what it was suggesting here? Oh, it's not suggesting it anymore.
Yeah, because now we are doing n-1. So now we are not doing the call of j. We are doing math on top of it. So luckily we didn't accept the int before testing the code. Now we have a flip horizontal and flip vertical. You can also leave a comment. This is rotating 90 degrees clockwise. So we remember for the next time, because this is a very long advent of code exercise. I remember that last year I stopped on this one.
Yeah, everyone is complaining.
Yeah, last year I stopped at the 19th because we had in our company challenge on top of this. I was already winning, so I said, okay, nothing. I'm not playing anymore.
Do we do flip horizontally and flip vertically?
Yeah, we do two different flip. They will be very similar code. We can see later if we can generalize, but let's.
So I'm gonna copy paste all of that for now. But the difference is now that flip horizontally. Basically,
we just need to take.
We just invert every single row. Yeah,
every row must be inverted. It's easy.
So this one is actually quite easy, because here we can just use. We don't need enumerate, and we can just use row.
Yeah, and the row reverse row. I don't know if you can call
row, and then we call it rev row, which is gonna be.
Yeah, but there is not a reverse function in Rust to reverse.
Actually, you're probably right. So let's see, row dot reverse.
Cool. Done. This is a flip horizontal.
And why does it like collect?
At this point, can't you just clone the
Oh
row
no, wait.
and
This one is
doing in place?
yes. So we need to do a little dance
A
then.
row clone reverse.
Let rev
You
row.
can't row.clone.reverse. Or is
But
doing
it's
in
still
place?
not gonna return it.
Okay, sorry, you're right. Okay, row clone and then rev row reverse. And yeah, but you have to call reverse on top of the. No.
Oh yeah, sorry.
Okay.
You're right.
Let
We need
mutable
to do-
reverse row. Reverse is working in place.
Okay.
Now must be mutable in 84. Line 84 must be mutable. And the row
Oh,
clone
why
is
does it
complaining. You can't clone an array.
Try to dereference. So they are saying you can just do this. And it's the same.
It's the
Okay,
same.
whatever.
Okay. We need all the collect, vec, try into unwrap. We need all of that.
I think so because
Okay. Change the name of
let's
rotated to flipped just because
wait,
it's
let's
bothering
see.
me.
Let's see. Yeah,
Yes.
we need it. And I think because we don't really know the sides in this case.
Mm.
So it's we need to use a vector, and then from the vector we try to map that vector into a fixed array.
Just a more comment. Rename the variable in line 80 rotated cells to flipped cells.
Good catch.
Or new cells. So it's just bothering me that it's called rotate, but they are flipped. That is me being picky. Sorry.
Okay, now we can also duplicate the test. Flip horizontally.
Mm-hmm.
And now
Flop ties.
and now this is gonna fail if we leave it
Yeah,
this way, but what we can do is this, or we do the DBG trick. Let's do that
yeah.
because I'm lazy. Okay. Let's see if it makes sense. Yes, looks okay.
Those are
This
the
is just the
borders.
way. This is the borders. We need cells.
Okay. Yeah. DCBA. Okay. Yeah.
And now let's do this and this.
Okay. Rename the variable in line 300. Move the debug. Try the luck. But we know it works. We copied.
But yeah, we can see that A, B, C, D, A, B, C, D.
Is
Okay.
now
So
flip
now,
vertically is just reversing the tiles.
so now we want to do flip vert, and again self.
Why is
Self.
complaining in line 79?
Because we are not using it except in the
We are
test.
using it in the test. Well, okay, fine.
But I think the test is considered another package.
Okay.
So we are not using it in the main package. So either you expose it as a public
No, I was
functionality.
thinking I was thinking that using it in the test was enough.
Okay, so now we can do probably better to do this one, right?
No, but because we just have to copy the original one and reverse on the first level instead of the second one. Can we clone the cells and just reverse them?
Can we clone?
Because it's a nested structure.
Oh
So I don't know
yeah.
if
So
we can
basically, what
clone
we can do,
nested
let
structure.
flipped
let mutable flipped because we have to reverse works in place again.
Yes.
With
To
the star at
self
this spot.
dot cells.
Yeah, but with the star because
Let's see if it's complaining again. Probably yes. Or not, because maybe it's unnested. I'm not sure.
My question here is, due to the fact that the array contains arrays, clone is working on both levels or
Probably not, but let's see what happens.
the flipped cells reverse?
So it's like a shallow clone, it's not a deep clone.
I don't know. I was asking.
Actually, let's search for it.
Because this structure is complicated. I mean, it's not a flat array, it's an array with arrays. And we want to flip the order of the arrays in the arrays, but if we copy a bunch of pointers, they are still pointing to the original cells. We are not pointing to a copy of them. We are just flipping the array of pointers.
Or
But
it's probably...
this is reasoning in C, not reasoning in Rust. So
yeah, I expect it's cloning everything, like in a deep way.
okay, let's try.
But I don't know. Because it's going to return a copy of every array, so a copy of every array I think is copying all the items as well.
Yeah,
but...
because if he's copying the reference to the items, it's different. But let's go on. Flipped cells reverse and retard flipped cells. Nothing else. This one is easy. If the clone is not.
No, we need to return this.
Yeah, sorry. Yeah. You have to return a tile. And now he's complaining.
Now. Yes, so he wants this. With parentheses, probably. Huh? Wait.
It's a complex structure.
What was the suggestion? Try removing clone and just self cells. So by assigning it, you are already copying it. I think there is a difference with the clone trait and the copy trait. As far as I remember, the copy trait means every time you use that value, you are copying it by default. Instead, the clone trait is if you want, you can clone it, but you need to explicitly call
do
.clone.
that. Yes, here we are working with arrays that are very basic level types.
So here we do flip vert. And again, let's comment. And this is flip vert. PBG flipped. Now lazy copy paste.
Not that one, those are the borders.
Yeah, oh yeah, you're right. Cells. Now this one is consuming the value. If we remove it, it should be fine. And let's see if it makes sense. So A, E, E, I, M, M. Yes. N, J, J. Yeah, works. Cool. So now we have these three helper methods. We wanted to create another function that... Does it make sense to put it inside a tile? No, right?
But it's working between two tiles and looking how the second one must be rotated to match the first one.
Yeah, let's do it as a standalone function.
If we want to override an operator, I don't know if there will be a good one to do this, but
let's not do it.
I don't think so. It can go inside the class, the struct. How they are called in Rust? Class interfaces struct. Oh, well.
Struct for yeah, I think struct is the correct terminology. So fit tile left makes sense as a name.
Tile.
So you are trying to fit a tile, on the right side.
Yeah, the one that you assume to have is the one on the left.
So
you need the left one, and you give the right one, and we know that they somehow touch, and we have to understand how they touch.
And what do we return? A new tile, which is the rotated right?
I don't know if we have to rotate also the left one. Listen to me. You have a border. You have the initial corner again. The initial corner, and you have his tile that goes on his right because we put it on his right. But they are matching with the top border of the corner and what you have on the, for example, right of the second tile. So you have to rotate these by 180 degrees, but these must be rotated 90, and then they match. Right?
So I suppose if you want to make the function very generic, yes. But I am starting from the assumption that we always have one tile anchored
that
has been fully positioned and decided,
so
and
the
left
one is always the left one is always right. Okay, so we can give.
And by the way, we also have in the borders, we have already the positions. So we could literally check that right border here and just see if the other right border matches. Sorry, if the left border matches, is already rotated correctly. Otherwise, we need to keep rotating and flipping until it matches.
We can see which one are we matching, and then we can just do one. Instead of doing in a loop, we can do just exactly what we need. Just to be, we can give back a tile. Yes, the answer to the question about types is we give back a tile that is the same tile, the right tile, but rotated or flipped in
accordingly,
the right way. Accordingly.
So it could be like a straight copy if it's already correctly rotated.
Yeah, we can return it. Also, we are taking references, like always, because otherwise we are consuming the tiles.
Very good point.
And we have to do these multiple times, so we can consume them.
Okay, so let me do something very quickly just for my own sanity.
Copy, yes, that one in a comment.
Now what I want to do is constants, I guess. Like top is gonna be 0.
Our top will be 1.
Why doesn't like? Oh, because const you need to decide two sides. You need to give it the type because it's outside the function. Sorry if this is boring, but I think we're gonna avoid mistake and weird code.
Don't you have a command to do uppercase in VS Code?
Probably.
Select all the line, Ctrl-Shift-P, uppercase. Yeah, select all the line until the end.
Oh yeah, good one. Let me do this one first.
Uppercase. Okay, so you write a little bit less. Then you could have done everything in the starting. You can put everything in a new line and go multi-cursor. Yeah, exactly.
Why this one?
That one. No, 8, 7. No, 7. Why?
So yeah, you're right. This is 7, 6,
5,
5, 4.
Got
Perfect.
it.
So now we can easily access every single border. And basically what we want to do is, I'm gonna do the dummy case first. So basically if
left
dot borders
right, yes, my god,
is the same as right borders
left,
then like job done.
Yes, return new tile. This we can implement clone at this point. Tile right.clone.
So basically we just return right. Which
Yeah, but right is a reference. We have to return a new tile in our clone. And we can already clone it, or and also return and semicolon because you're not in the last line of the function.
Do we need to say n?
In the type?
It's interesting that it's not inferring that. Oh, because here we can just say self. And can we just say self this way?
So we can say self. We are not inside the function class. Self.
Okay, that's why we need to do that. Then look at this. We need to do a little crappy thing. Const usides n.
Also in the parameters.
I'm not sure that this is the right syntax. I'm gonna check in a second. Const n usides. I think that's the right syntax, isn't it? Const n usides.
Do you want to put it inside the tile so it's easier?
Inside the tile, we could.
Yeah. And we just pass right.
But that should work. Now I'm not remembering the.
Try to Google it very. Also, we are at 1 hour mark. I don't know if you want to go on.
Const generic on function. What doesn't like it? Expected function. Oh, maybe this one goes on the right side. Okay, cool. That is the syntax.
Okay.
Okay, now this one does not implement clone because we only implemented that. Now should be up here. But of course,
return right clone.
If we always return this, hopefully it's gonna be up. Okay, now here, why does it like it?
Because we don't have return and the semicolon.
Expected unit type.
We don't have to write return right clone semicolon there.
You're right, because otherwise it's returning the if statement. Okay, cool. So I'm wondering, can we put this in a loop?
Yeah, but based on the one that we match, we have to do different stuff: rotate twice, once, 3 times, flip, not flip, and so on. So yeah, we can do if else if else if else if else if that then will become a match probably in the end of the days. We can already start with a match. To be honest, it's simple: match left border right. If it match right border left, we return right clone. Otherwise, we do other stuff.
So we match this guy.
Yeah, we match that guy against the stuff. And we can return directly the match itself. If he's matching right border, if he's matching that one, exactly, we return the right clone.
Actually, we can just put the return here.
You don't even need that one because I think we'll be the only one.
Oh yeah, exactly.
You have to remove everything down. Yeah. Clone, comma. You need a comma.
Expected comma. And then I'm curious just to try this.
Just to have it working. No, why is complaining?
Wow, today I don't even remember the syntax
of a match. We have match everywhere.
It's match and a value, and that's correct. Then you put, okay. Do we need to put parentheses? Missing comma. Yeah, if you put parentheses, it's considering it as a tuple.
Yeah, but we want right borders left. And why this is not doable?
Yeah.
What is again the error? Sorry, can you over it? Can you over on the suggestion error or whatever it is?
Expected comma.
Expected a char of end, okay, a border, but we found a tuple with 3 elements.
Because I put the parentheses. Just 1 second. So if we say X, now it's going to complain that X is not the right type.
Yeah. Try again to put what you had before. You don't have commas in this stuff?
No. So it's right dot cells.
No, borders.
It doesn't like it. Maybe we cannot have expressions there. Maybe we cannot have an expression.
Assign right borders to a variable. Let right borders equal to right dot borders.
It will be right tile left border, right?
No, but just not everything. Just right dot borders.
Let me try this for a second,
Okay.
just to make sure it's happy. What? Unused variable. I mean, it is used.
The fat arrow is the right arrow, or is not the fat arrow? Is the fat arrow, yeah.
Yeah.
Okay, no, just asking, sorry.
I'm getting confused.
I'm getting confused too.
Let's do the right borders, because at this point I'm curious.
What is right dot border? It's a char of something.
I don't think we can put expressions here. That's probably the issue with match.
Okay, let's go with if, and then we refactor another day.
Scusa, non ho capito.
Scusa.
Sorry, Google Nest is catching up random sounds. Yeah, return and the semicolon, because we are inside an if. Okay. Else, and yes, we have to do all the cases if it's matching.
So what are all the cases?
It can match right border left, right border rotated left. At that point, we just have to flip horizontally.
Mhm.
Right borders, we have left. You right dot borders because you deleted the
I
variable.
didn't, yeah.
Or
Why
you
didn't
do,
complain? So this is, what did we call it?
R left.
left.
If he's matching R left, it means that we have to flip vertically. Sorry. And we're done. Then what if we match with right? If we match with right, we just have to flip horizontally.
Correct, okay.
Now you can copy the line 115 multiple times. There is probably a way to do this in a smarter way, but
So if it matches right,
borders right, we have to flip horizontally.
okay, then
If it matches reversed right, we have to flip both ways. Flip horizontal dot flip vertical. You have to change the two flips. I don't think the one you do before is changing something.
really? Well, I'm not sure.
No, I don't think it's changing. But one is working like this, the other one is working like that. Now, what if we match the top one? If we match the top one,
We need to rotate 4 times. 3 times.
we have okay, let's a moment. I'm reasoning because we have to do this, but also this.
Do we?
If the top border is ABCD and we have ABCD, they match, right? If we just rotate, we have A here and A here, so we have to also flip. Sorry. I can be wrong, but if we match the top,
So this is top.
yeah. If we match top, when we created right, we went from above to bottom, top bottom. When we created right, so if we just rotate 3 times, we have it like this, but then we have also to flip it vertically. So
Perfect. So we need to rotate.
3 times because we are rotating the wrong way. So
No, we are rotating clockwise. So one time.
So like this, but then you're right. We can rotate once and then flip horizontally.
Correct. Okay. Rotate and then flip horizontal.
Yeah.
Jesus, we'll need to test all the stuff.
Yeah, for sure, because we have to
and
take
then
2 times.
Reverse stop is just rotate right.
Okay, sorry. Rotate top, it means that it's like this, so we have to just do this. And to do this, the fastest, we have to rotate 3 times because we are rotating the other way.
No, wait, we are rotating right. Clockwise. Right? So ABCD will become ABCD. So we rotate clockwise.
But if inverted top is matching with the right of the previous one, if we rotate, the top will go on the right.
Oh yeah, we want the ABCD to be on this side.
On the other side, yeah. So we have to rotate just 3 times.
Oh my god.
Because it's like this. So yeah, we have to just this, do this, we go the other way around. Rotate. So probably it's even easier to create a counterclockwise rotate, but not now.
Now we have
let's
right.
For bottom. No, right, we already have right. We have to do
We
bottom.
we have what, left, right, bottom is the last one.
Yeah, bottom is that. So let's go bottom. Bottom is just rotating once.
Bottom is just rotating once.
Bottom is like this. To make the finger matching, you just have to rotate once.
I like the idea of using the finger.
And the last one is this one. I'm breaking my shoulder. You have to rotate once and flip vertically. There is a vertical flip. This can be probably reduced to, but not now.
Now unreachable.
Unreachable. In theory, unreachable code, because it means that we have two tiles that are not matching. If the previous one are turned in the right way, because it can be that we made a mistake.
Okay, I don't know if I want to write a test because it's already
more
than 1 hour.
We can close here and go on next Monday probably, or
Yes.
before if we have time.
Just to recap what we should be able to do at this point, we probably need to do another fit tile bottom, right?
In theory, if we are lucky, no, but probably instead we'll need it. And it's very similar to this. It's just change the one that we are looking is not right, will be bottom, and change a little bit of logic. But next time I don't want to do that.
So maybe we'll write tests for this one. If it makes sense, we do the same thing for bottom. Yeah. And at that point in our algorithm that we already have, every time we are placing a tile, rather than placing it straight away, depending if we are placing it on the right side or on the bottom side of a tile already placed, we just need to rotate it, and then we place the resulting one. So we need to use this fit function and just place the one resulting from here.
Yes. Now in our
point,
tile map, we just have numbers. We don't have tiles. We have to create a tile map with tiles.
Yes. Yeah.
That will be called
with actual tiles.
Yeah, with actual tiles, not just with the idea of the tile. But that is just doing it. And then after that, we have to create a full new image out of it. Then there is another stuff to do on top of it.
And then still we're not finished, because at that point we need to find the patterns on that final map. This is going to take a long time. And then we also need another helper function, probably is going to be here to remove the borders.
Yes, give me the cells without the borders, yeah.
Okay, cool. So we are going to stop here. I'm going to do a commit later, because I think all our tests are working. Let's just double check to be sure.
I run all the tests just to see.
Yeah, we have a new stuff, but everything should be working.
Perfect. So yeah,
what do we have? What are we printing? Oh yeah, we still have a lot of DBG. Let me remove that because we don't need it.
Yeah, from yesterday when we were trying to debug why we got out of bound. And the reason now we already explained it was we were adding to the stack in the wrong order.
Let's leave this one for now. Okay, cool. So run the tests. Cool. Perfect. So I'm gonna stop here and we'll do the closing. So thank you everyone for following today. Again, we do Advent of Code live on Twitch. So if you are watching this video on YouTube, make sure to check out the description of the YouTube channel to find the live stream on Twitch. And we accept PRs. As you can see, our Rust is very non-idiomatic, I'm going to say. Yeah. So if you know better ways to do the same things we are doing in Rust, please send us PRs at this repository. We really appreciate all the help we can get. We are doing this just to try to learn Rust. This is kind of an excuse to keep us accountable. So we'll take any help we can get. And what else can we say?
Do we want to ride?
I'm going to skip the raid for today as well, because I didn't search for anyone. But yeah, thank you everyone for following. Also, we got a
Thank you.
follow right now, so thank you very much, Im Joshua, for following us. Hopefully, we'll
Thank you.
see you next time.
See you. Bye.
Bye.